Howdy, everyone. Before I start this presentation, I'd like to get, or ask you all a little question. Who here likes to write unit tests? Okay, laughter, but no takers for that. All right, you're gonna love this then. Today I'm going to be teaching you how you can write unit tests autonomously using DeepUnit. But before we jump into that, for anyone here who has never written a unit test or maybe doesn't write code even, I'll explain what a unit test is. So fundamentally, a unit test is simply taking a unit of code, a single function, and we're writing a test to prove that that function works or does not work. And it's fairly tedious and a pain in the ass, and no developers like to do it. So we've built an AI for you that does that. So let me go ahead and I'll walk you through how it works. So under the hood, we have an agent, like Alex just demoed, that will take a look at your code, grab what we call the least minimal context necessary, and figure out what that function and its context does. And based on that, it'll sort of build a summary, and then it will write a unit test. And that means end to end. It will start by building out the entire file. It will come up with test cases, and then it will assemble those test cases and the code for those test cases into a full file. It will run that file, fix any errors, and when it's done, it will return you a file. And at times that file may fail if there's a bug in your code. DeepUnit does at times find bugs, but generally speaking, that is how it works. So we're gonna go ahead and we're gonna hop into doing that. But before we do that, I'm gonna go ahead and explain a little app that we're going to be seeing how you could write a unit test today. Now DeepUnit is actually available in a couple different flavors. We have a VS Code extension, we have a command line tool, and we also have a CICD pipeline. And today we're going to be seeing the CICD pipeline integrated into GitLab specifically. So I'm going to go ahead and we're going to write some unit tests for this sign up page. So this sign up page is, it's your classic sign up page. You could type some things into it, like your name, your email address, or your password, and then create an account. And if you don't do that correctly, it will give you an error message telling you which fields are missing. And under the hood, this is an event-driven reactive architecture. So if I type in my name, after every keystroke, we recompute that error message. And because I've typed in my name, the name field is populated now and removed. And now we only want a password. And finally, if we use a strong password, we have nothing required. So this was a really nice, form. I worked really hard on it, and I opened up a pull request and I put it into GitLab. So what I've said is I've indented DeepUnit generate form error. That is the function which generates that error message for you. And I've indented it so the DeepUnit will recognize that it's been changed. So let's take a look real quick at what this function does. It first checks that the form is valid. And in the case that the form is valid, it will set the form error message to be empty, and it'll cancel the subscription and return. And we won't continue on. In the event that the form has any errors though, we will continue on. We will check every input, and if the input is invalid, we'll add it to the array of invalid inputs, and then we'll go through a fancy for loop that generates the error message and displays it for the user. So now we know how that works. The DeepUnit bot has seen that we've opened up a pull request, and it's generated some unit tests for us. And it has asked us to review them to merge in. So let's go ahead and take a look at those. So we can see here, the first test case that I wrote is checking if the function is valid. That is that first if that returns if the form is valid. And so it will go ahead and look and set the form. The initial error message is just null. And then we run that function, and we expect that we get null as the error message, which we would get. So there's the first test. And so we can go ahead and we can look and we see that the tests actually have passed. The pipeline that runs our test for us ran. And so we successfully have generated tests. And there's not just one test in there, there's a bunch. I'm just not going to go into every single test view today. But that is, generally speaking, how the DeepUnit tool would work in a developer's workflow. All right. So DeepUnit is really, really easy to do, so easy that it doesn't take that long to demo. And so I'm going to give you a bonus demo today of a second tool that we built. So this tool actually arose out of an internal need of ours this week. It actually was inspired by Alex, who just spoke. One day we were sitting around. He's like, you know what is a pain in the ass is uploading files to S3. Who here doesn't get a little confused every time they need to open the S3 console? Anyone? Okay, a couple people aren't confused. You guys must be like, oh, okay, no, okay. I think there's still one guy. Okay, you must be just like the ninja DevOps guy. I'm going to call you next time I need to deploy something. But until then, we built something for you called Easy S3. So the use case here is we built a little video generator with AI. It's kind of a side project of mine I've been working on. And after it generates a video, it needs persistent storage. So enter S3. And I don't like dealing with S3, and I like to automate things that are a pain in the ass. So I built Easy S3, and I'm going to go ahead and demo it for you today with this little upload form that I built just to demo things. All right, so we're going to upload the flyer image for this event today, and we're going to get an error message because we can't upload to S3. This is not yet implemented. So if we go into code, it's very, very easy to upload something using Easy S3. It's in the name. You just simply install, so npm link easy3. So it's not yet published to the npm registry. We'll also publish it to the pip registry. But this is how you would install. You would replace link with install, but it's link for today. That is the local version of install. So go ahead and make that small. So we're throwing this error message here. Oh, before I forget, this is our controller for that, the backend for that form that you saw before. So there's a file controller. It has an endpoint called upload, and it takes in a file. And we write it locally. It hasn't been written to S3 yet, but we want to get rid of that. So instead of throwing an error, we're going to say upload response equals easy3 dot upload file. And then this file path, I believe, was the file. Yep, there's the file. And it should, there needs to be an await there. All right, and we get back, there's one item, it is the path, and we're going to return that. So now if we go and we click upload, it is uploaded successfully, and it's been uploaded to S3. And let's go ahead and download that, and we see our file got downloaded, and it is this events flyer. Sweet. Very easy. All right. Hope you've enjoyed the demo of these two tools. So go ahead and sign up for either of these if you're interested. Just scan the QR code and you can sign up. Now, are there any questions about either DeepUnit or Easy3? So the hard part of writing unit tests with DeepUnit from our side when we've been developing this, it's not the writing the test case or writing that one function around the test case, but it's doing the data setup, it's getting the dependencies mocked, it's all that stuff. And that's where really most of the effort of this tool goes into. It's very easy for you to just copy paste the function you want to test into ChatGPT if you want to do that. And you'll get a maybe good response depending how much dependency there is. So what DeepUnit does is it doesn't just look at your function. What we do is we parse out the AST of your code. We look at that function and we look at its dependencies, and we go ahead and we map out within your code base what other dependencies matter, right? Perhaps there's a service that's injected into whatever file you're editing, and that service is used, and that service maybe has some other dependencies, whatever. And so we figure out what do we need to pull into the context in order to mock correctly, and what sort of data needs to be present during that mock. So the code base, yes, it is being sent to our servers. For a company which has privacy policies and cares really deeply about not having their code be leaked, we can offer an on-premise deployment. So additionally, your code goes to OpenAI if you choose to use OpenAI models with this. However, alternatively, we can use other model providers, or we can simply host something within your cloud. It's been on our to-do list, actually, is we want to build out almost like an agent ops sort of a thing, but something a little more custom and homegrown because unlike other agents, the success metric here is, does it successfully write tests that compile and run and at times actually fail or, don't pass because there's maybe a bug in that code. And so we want to build out sort of like this table where we can look at past versions and basically build out a CICD pipeline that clones a bunch of repos and then runs DeepUnit in those repos and then looks at the output and does some sort of like judgment as to like, is this a good test? Yes or no? Does it work? Compile that all sort of thing. The TestGen LM was actually really interesting. I really enjoyed reading that paper. For those not familiar with it, they use something called LMSE, which is LLM-based software engineering, wherein effectively you build out a success metric to measure an AI-powered software engineer such that it measures that it reliably and measurably improves a code base. So, for example, DeepUnit, it technically complies with this in that we can reliably measure an increase in the number of unit tests and such. I actually went into a lot more depth on this. I wrote a Twitter thread. You can go ahead and go to my Twitter. It is GPT Justin, and then go to my media tab. There will be not that many posts that have media. There will be one that has a screenshot of the Facebook paper. Code semantically says what it should do, or hopefully it does. In the case that it's not semantically clear, it may not be able to tell that. However, sometimes we write, off by one errors, or we write code that has some bad assumptions. And although the code says it will do one thing, it does not in fact do that. And so when it writes the test and the test expects a thing to happen, but the code does not do that, it will catch that. So I can give one example actually of DeepUnit catching a bug in its own development. So somewhat early on in the tool's history, we went from taking one potential command line flag to taking multiple. And the file for which takes in those command line arguments assumed there would only ever be one. Of course, when DeepUnit ran and it was expecting multiple command line flags in the new unit test that it wrote, that didn't work because there was a possibility that there were two, but we hadn't tested with that yet personally. And so we realized, oh, great, we need to fix this bug before we push, because users will be very disappointed when only one of their flags work. Primarily privacy. Some companies we've spoken with are concerned about if OpenAI gets access to their code, will it end up in a training data set for a future model? OpenAI does say that will not happen, but some companies do not necessarily trust their assurances. Generally speaking, GPT-4 gives the best result of all models. There are some cases, however, I actually like the test cases. So that is just the case and not code from Mistral better. Llama 3 is not terrible, actually. I'd say it's like 70% of GPT-4. Yeah, you could totally hook up DeepUnit with OLlama or something, and locally. You probably want to use like the 400B parameter model, but I actually like Cursor. It's really cool to watch it go through things and be like, oh, I'm editing it for you. But actually, GPT-4o has been really, really cool recently, actually. It is super fast, a little bit dumber than GPT-4, classic, but very cool being able to have it so fast. Just cuts down the iteration time so much. I mean, DeepUnit writes unit tests for itself. almost constantly. I mean, like those CICD pipelines run on every change. So it does run on itself quite a lot. But yeah, that's been one of our to-dos is we actually want to be able to like test very minor changes in the prompt. Like if we just change a couple characters or something, like what would be the effect? So far, it's just been artisanal prompting, but we want to be able to have it actually run on like 50 different code bases, basically building out like a pipeline for that to clone them all and run it, and then hit an endpoint and like upload that data. My thinking on this was, I started this, before GPT-4 came out, I think, or maybe it's a little after, I'm not sure. But basically the problem was you have models that have limited context windows. I think it was 8K context when I started this. And I thought it would be very difficult to get the entire context of an app, a whole application running in an end-to-end test, multiple pages and such. But a unit test, those are fairly confined. You have a file and then maybe 2 or 3 dependencies deep at most that you really need to understand. And so that is why we started with unit tests. Really, if you just want to prototype something quickly and like get something that has persistent storage up really fast, it makes it a lot easier. Just like, do you want to spend an hour or two like messing with AWS? But I would actually love to hear from people in the audience if they have their own use cases that they could see being useful for this.